let's try to solve the simplest one. Question. Z to the third power equals 1. And, just to make it look a bit more familiar, let's do it this way. X to the third power equals 1. Now, you feel like you've solved this kind of questions before, right? How do you solve it? You subtract 1. This factors as x minus 1 times x squared plus x plus 1 equal to 0. Hopefully you've seen this factorization before. How many of you seen this factorization? Just out of curiosity. Seen it? Like half of you? Okay. Just FOIL this out and you'll see that same as that, okay? So either x minus 1 is 0, which gives you x equals to 1, obviously. 1 cubed is 1, so that's a solution, definitely. But this is another solution. And since this is a quadratic equation, we will use a quadratic formula with a and b and c, all of them being 1. So how does that work? That's negative b plus minus square root of b squared minus 4ac all over 2a. That's the formula. And because a, b, c are all equals to 1, we get negative 1 plus or minus square root 1 squared minus 4 times 1 times 1 all over 2 times 1. And that gives you negative 1 plus minus square root of negative 3 over 2. And because you see a negative inside the square root, you can rewrite this by saying that x is equal to negative 1 plus minus radical 3i. See, I'm breaking up square root of negative 3 as square root of negative 1 times radical 3, and this is equal to I. So that's why I'm rewriting it like that, all over 2. And therefore the answers are x equals to 1, and then you have negative 1 over 2 plus square root of 3 over 2i, and negative 1 over 2 minus square root of 3 over 2i. Do you recognize this from somewhere? We were playing with these a moment ago, right? So for example, what is this guy? What's this angle? 120, right? So this one is the one with negative 1/2 here, radical 3 over 2i, 120 degrees, right? That's what it is. We had an example problem just a moment ago, right? And when we called this as z, what did we find? Z cubed was equal to? You can go back to your notes. What did we get for z cubed? 1. Right? Of course, therefore, this is a solution to this. Right? If you take the third power, you get 1. Kind of obvious, right? Because if you have 120 degrees, and if you multiply this by itself 3 times, it's 120, 240, another 120 added to 240, you get 360, so you come back to 1. All right? So in other words, this is cosine 120 degrees plus I times sine 120 degrees. In the view of De Moivre's theorem, if you take the third power, what happens? That just simply gets multiplied. Just like that. The 3 just gets multiplied. Of course, you can call it De Moivre's theorem, or if you just rewrite that in terms of Euler, it's obvious that 3 should multiply. But what is that? That's cosine 360 degrees. 360 degrees doesn't do anything. It's the beginning point of the unit circle. It's right here, which is 1, right? So obviously that's going to be a solution to this. Okay, so if you notice this, then but what about this one? I should also talk about this one. This one would be angle what? What would be the angle of this one? Well, in this case, it's this one, and you have two options. You can call this at 240 degrees, or you can call it as negative 220 degrees. For the solutions that I'm going to do later, we'll call it 240 degrees because that works out better. Okay. Now, let's think about the third power of this guy. What is that? That's like taking this and taking the third power. Again, what does the De Moivre's theorem say? 3 times 240, right? I sine 3 times 240. 3 times 240 is 720. What's that? That's 2 circles, 2 full circles, right? So it's like going around this twice, and you come back to the same thing. Where are you at? Again equals to 1. So that's why this taken to the third power is going to equal to 1. Okay? Now it's very important that you understand what's going on with these, because I'm now going to explain the second method. So here's the second method. And while we got lucky and we were able to come up with some factorizations to get the solution this way, you can only do this if you know how to factor. In general, you'll be just stuck with the second method, right? So you really need to pay attention to this one. So what we do is let x be equals to r times angle theta. All right. Then x to the third power would be, it's like r times angle theta, r with angle theta multiplied by itself 3 times, right? What's this if you multiply these two? What did I say about multiplication? The magnitudes? Just multiply. How about the angles? Angles add, right? What's theta plus theta? 2 theta. And then you have another r angle theta. Magnitudes? Magnitudes? Multiply. Angles? Add. Okay? And you can say that this is the De Moivre's theorem. You can say this is De Moivre, because if you take the third power, the angles multiply. Okay? Now, I only spell this out because it's the first time, but later on, you should really just be able to go from here to there without going through each individual step. It's like x, if it was x to the fifth power, it's simply r to the fifth power 5 theta. Shouldn't be that bad, right? Okay. Right. Now, you need this to be equals to 1. But what is 1 in terms of magnitude and angle? 1 is, of course, magnitude 1. What's the angle for 1?
0.
0, right? Angle for 1 is 0. We said 0, okay? So once you write it like that, then we have the following identity. We have x cubed equals to 1 can now be written again as r cubed angle 3 theta equal to 1 angle 0. Okay? We're just viewing this in a completely different way. Yeah. And the beauty of math is that sometimes changing the way you look at things makes things a lot easier. This is an example. See, r cubed is the magnitude and has to equal to 1, so r cubed equals to 1, therefore r must be 1. Because r is a positive real number, right? Yeah. The only positive real number whose cube is 1 should be just cube root of 1, which is 1. Okay? So there's no surprise there. You can really just say cube root of 1, which is just 1. Okay. Now 3 theta has to equal to 0. What does that mean for theta?
0.
It'll be 0. So that tells me, putting these two together, I see that x is equal to 1 angle 0. What's that? What's 1 angle 0? On the picture, 1 angle 0. Here, right? What's that? Size 1 in the direction of angle 0. What's that number? 1. Yeah. It's 1. Oh, but wait, we need 2 more answers. How do we get the other two answers?
Sine, cosine.
No, that's too fancy. What's happening is that this angle, so I wrote down 1 as 1 angle 0, but there was a case where 3 theta ended up being 360 degrees or 720 degrees, right? So this can actually be 1 angle 360 degrees, or it could also be 1 angle 720 degrees. So you have the other two cases where 3 theta equals to 360 degrees. What's that? Theta is 120 degrees. So that means x is equal to 1 angle 120 degrees. And that is exactly this picture, which is, if you write in longhand, this is 1 times cosine 120 degrees plus I times sine 120 degrees. And that's equal to negative 1/2, and this will be plus I times variable 3 over 2. Unfortunately, if you forgot your tricks, you should study them again, because you need to know these things. Okay, and then the other one, 3 theta could be 720 degrees. In that case, you get theta equal to 720 divided by 3, which is 240. So you get x as 1 angle 240 degrees, and going through the same motion, we get the other one. Okay? So we cover all of those 3 answers without having to know this formula, x cubed minus 1 equals x minus 1 times x squared plus 1, x plus 1. Okay, so remember, the first solution looked easy, but it was only easy because we knew that formula, right? Therefore, this is the one that would generally work. Okay? Yes?
What would happen if you went another 360 degrees beyond?
Oh, yeah. Then, yeah, thank you. If you add another 360 to this, it says 1080, right? But that gives you theta as 360 degrees, right? But what is that? What's 1 angle 360 degrees? Yeah. So you get the same solution as before. You don't get a new solution, right? So in other words, the idea is you keep adding 360 degrees until you don't get anything new. It will always happen that way. Another way to say it would be, it's a 3rd degree polynomial. How many solutions can you have at most? 3. Because I already found one solution, x equals to 1, x equals to this, x equals to this. we already have 3 solutions, so there is no point in doing any more. We know that anything that you get extra will be same as the previous ones that you started with. Okay. All right, so I only have 10 minutes, so let me squeeze in z to the 6th power. Oof, all right. 6th power is going to be equal to negative 64. Yeah, so let's do it that way. Okay, negative 64. Okay, solution. Set z as r angle theta. And that means z to the 6th power is what?
Part of 6 theta, angle 6 theta.
Okay. We also need to change negative 64 into r theta. What's the magnitude of negative 64?
64.
It's a 64, right? It's length, or you can think of negative 64 as negative 64 plus 0I, and then the norm of this is what? The magnitude is square root of negative 64 and then 0 squared, right? Do not include I in this formula. Never do that. That's a common mistake. It's this number squared, whatever they are. You add the squares up and then take the square root. What is that? That's square root of 64 squared. They cancel, so it's 64, right? So that's one way to do it, but you can also just picture it. What is negative 64? It's on the real, this is imaginary, that's real, so negative 64 is on this side, right? Negative 64, that's this. What's that length? Of course, the length is 64. You don't have to do all that, okay? So either way, you get that as length 64. What's the angle? It's going that way. What's the angle?
Pi. Right.
Pi, yeah. Its angle is pi or 180 degrees. Okay. Yeah, let's use pi this time. Now, it turns out that it's easier to use pi than degrees because if you use degrees, a lot of times you have multiples of 360 degrees. Those become too large. I mean, if you can still solve it with those. I'll just use pi this time, okay? So that's what we have. So that means we have r to the 6 angle 6 theta equal to 64 angle pi, which means r to the 6 is 64, and if you take the 1/6 power both sides with your calculator, you'll see that r is equal to 2. Or another way to see this is 64 is 2 to the 6th power. You can, you can solve this and you end up with r. This will tell you that r must be 2. Okay. On the other hand, 6 theta should equals to pi. So that means theta is pi over 6, or 30 degrees. Okay. So this tells us that the answer is z is equals to 2 angle pi over 6. And in many cases, they ask you to write the answer in rectangular form, so you have to rewrite this in terms of 2 times cosine pi over 6 plus I times sine pi over 6, which is 2 times cosine pi over 6 is square root of 3 over 2. Sine pi over 6 is 1 over 2. Okay. That means z is equal to square root of 3 plus I. Okay. But that's just one answer. We're looking for 6 different answers. Okay, so whenever you have this kind of thing, unless a is 0, you always get n different answers. Okay? So we're looking for 5 more answers. Okay. How can we get 5 more answers? Any ideas? You can rewrite this with another angle, right? What's another angle other than pi?
2 pi.
You can add another 2 pi to it. So you see, this pi means here, right? But you can go around. So add a 2 plus 2 pi, and that gives you 3 pi. So here's the thing. R will always be 2. It's a theta that could be different. So you have 6 theta that could possibly be equals to pi, or plus 2 pi you get 3 pi, plus 2 pi you get, what, 5 pi, plus 2 pi you get 7 pi, plus 2 pi you get 9 pi, plus 2 pi you get 11 pi. How many do you get? 1, 2, 3, 4, 5, 6. So you stop, okay? These are all the possible angles. And that means theta is equal to pi over 6, 3 pi over 6, 5 pi over 6, 7 pi over 6, 9 pi over 6, 11 pi over 6. Let's simplify this one. That's 1/2 pi, or pi over 2. And this one can be simplified as 3 pi over 2. Okay. So that gives us all the answers. And so let me write down the answers in terms of polar form, which is z equals to 2 angle pi over 6, 2 angle pi over 2, 2 angle 5 pi over 6, 2 angle 7 pi over 6, 2 angle 3 pi over 2, and 2 angle 11 pi over 6. Now, sometimes this is enough, okay? The question might say, find the solution, write your answers in polar form. This is enough, okay? Sometimes the question might ask for the rectangular form. So you have to change all of these as cosine theta plus I sine theta and get all the values. So if you did that, because of lack of time, let me just write down the answers. Radical 3 plus I is what you get over here. This will be 2i. This will be over there, so that's negative radical 3 over 3 plus I. This will be, let's see, where are we? Over there, okay, so it'll be negative radical 3 minus I. This will be minus 2i. And this will be, let's see, all the way, it's this way. So it's radical 3 over 2. No, just radical 3 minus I. Okay? So all of these numbers, if you took some time to take the 6th power, you're going to get negative 64. That's the answer.